Hey everybody, now we're going to look at some examples of solving equations with these, sorry, not fractional, but fractional coefficients. All right, so let's take a look and see what some good examples might be. So this first one we have here is I have 1/5 x is equal to 12. So if I look at this problem, right, I should hopefully make the connection that 1/5 is a fraction, it's rational, and that because it's a fraction, I can get rid of it by multiplying it by its reciprocal. So the reciprocal of 1 over 5 is just taking it and just flipping it the other way. We'll go with the different color here. Go with pink. And we're going to multiply that by 5 over 1. And whatever you do to one side in a algebraic equation, you do to the other side because it's a balanced equation. You have to keep things even from one side to the other. All right, so when I do that, my 5's cancel, my 1's basically cancel, and then you're left with x over on this side, and then we do the right side, and we've got 12 times 5 over, if you treat this as 12 over 1 times 1, which gives you 60 over 1, which gives us x equals 60, because anything over 1 is 1. All right, and so think about that. 1/5 of x is 12. Well, it's saying if you take 60 and you split it up into 5 parts, and you have, so that would be the 5 parts, and you want one of them, well, 60 divides evenly 5 ways into 12. And then if you only take one of them, that would be your 12. So that looks good. All right, let's try another one. We're gonna do about 4 of these all together. We have negative 2/9 d is equal to 4, and that's a pretty rough looking d, but we'll deal with it. So the number that is being multiplied by d is not 2/9, it's negative 2/9, and that's the connection you got to make on this. Is when you come up with the multiplicative inverse or the reciprocal for this, you have to include that negative sign because we want to get the coefficient back to being 1, not negative 1. We want it to be 1. So we're going to multiply this by negative 9 over 2. All right, and we're going to multiply both sides by that. Let me get rid of that. So we're going to go negative 9 over 2. We're multiplying both sides. Let's put the 4 over 1 so there's no confusion about it. And then you see your 9's cancel, your 2's cancel, and then both of your negatives multiply by each other. That's why you had to include it. Both of your negatives multiply by each other to get you to a positive d, which is what you want. And so let's take a look at, thanks. Let's take a look at this over here. So we're going to have 4 times negative 9 over 1 times 2. So that's going to simplify to negative 36 over 2. And if I split 36 into 2 parts, I get 18. And we have that negative sign there. So our answer is going to be negative 18. And so then let's think about this. This negative 2/9 is saying that I want to split this negative 18 into 9 parts. So that would be negative 2, right? Or we'll just say 2. Split 9 and split the number into 9 parts. So we'll say 2. And then we want 2 of them, so that would give me 4 parts, and then it's negative, or a negative of that negative. So it is negative 2. So that's how you get to your 4, right? So a little confusing with the negatives, but you can see how you arrive at the number, and just trust your integer rules about multiplying with double negatives and all of that. All right, let's try another example. So this one, 15 equals 5/3 n. Slight change up here. You're used to seeing the variable on the left side, but the variable can be on either side. It doesn't make a difference. So we want to deal with this is our coefficient. So we are going to multiply by the reciprocal and the multiplicative inverse of that. So we're going to multiply both sides by 3/5. If I do it on that side, I have to do it on this side. I'm going to put my 15 over 1. Okay, and then what that's going to give me is, if I do my left side first, 15 times 3 is 45. And then 5 times 1 is 5. And 45 over 5 is 9. And then over here, my 3's cancel, my 5's cancel, and that gives me to my n. So the answer would be n equals 9. And if I think about this, this 5/3 n means equals 15, means that I'm breaking 9 into 3 parts, so that means each part would be 3, and I'm taking 5 of them. So 5 parts of 3 would give me 15, which gives me to that number. So we're looking good. All right, last one, and this is going to be a bit of a review for some of you. We have 2 3/7 y is equal to 51. So this problem really isn't that hard, other than the fact that you got to remember how to deal with this mixed fraction, right, with this mixed number. Okay, so we've got 2 3/7. So the way we deal with this is you take the whole and you multiply it by the denominator. So you go 2 times 7, and then you add it to that top number, which is 3, and then that goes over the denominator. So that would give me 14 plus 3 is 17/7. So then let's rewrite this problem. You have 17/7 y equals 51. And then it just becomes like all the other problems, where we're going to take that and we're going to multiply by the reciprocal, which is going to be 7/17, and we're going to do the same thing over here. We're going to multiply by 7/17. And then when we simplify it, our 7's cancel, our 17's cancel. You get y over here. And then 17 goes into 51 3 times, and it goes into itself once. So then you're left with 3 times 7 over 1, which gives me 21. So y equals 21. And so if I think about this, 2 3/7 of y, if y is 21, well, that's saying that I get 2 wholes, right, which would be 42. And then it's saying I would take 3 parts of 7 from 21. Well, you can break 21 into 7 equal parts of 3, and 3 of those would be 9. So then you'd have 42 plus 9, and that gets you to your 51, which shows us that this works.